Hello guys, my name is Kate, I'm lead of integrations team, and today we're going to talk about DEX on top of Sharded architecture, maybe with those DEX on top of shards. So let me introduce our team. So integrations team usually in charge of three main directions. First one is we are builders for the system on top of our cluster, so we are building hardware for developers, we are building indexers and lots of applications which developers will need in process. We are building any DEX showcases as a proof of concept to understand if the process of development is smooth enough. Is it real to run some DEX or related protocols on top of shards, and which main features can be applicable from sharded architecture on top of main DEX. And yes, usually we helps to integrate any products and projects with the external teams. We discuss in use cases, we discuss main issues, and we can help from cluster side to do something to make it better. So our goals for today's presentation, I want to share with you some features from our cluster which can help to build some very new DEXs. And we want to inspire builders and give some kind of starting point of exploring this. How to achieve the best market fit for DEXs with shards, how to just be involved in this process. So let's discuss it. Let's start from the roots. So DEX stands for decentralized exchange. Some points here, they don't have QAC process. For majority of DEXs, they don't have any market makers, only mathematical functions. They don't have usually again user balances. If we talk about just DEX for with AMM for swap. And swap initiates a transaction in blockchain, of course. Why we choose Uniswap and why we choose V2 version for our experiments? So, Uniswap number one in the apps, number one from all the products on top of in chains, at number one in Ethereum. So developers already knows how to use it and how to build something. I think we have some guys here who already tried to fork DEX, and usually it may be just very first project for Solidity developers. So yeah, you already know how it works. You already know how you can use it. That's why we don't want to build something from scratch. We want to use something which already known by all developers to highlight and to learn all of them with some new features from cluster. Let's talk about Uniswap architecture. So basically, Uniswap have three main contracts. Two of them is core contracts and one the periphery. Factory contracts create unique smart contract for pair. Pair contract responsible for swap. And router contract acts as router and balancer on top of pair contracts. And so let's discuss the first approach. Let's improve usual Uniswap architecture, which already exists on top of Ethereum. So here we have EUA and router and pair as usual smart contracts for this flow. And two contracts for swap, USDT and USDC, which acts like for meeting and burning tokens. So usually Uniswap do two calls, one for transfer, next one for swap, and last one from clear to last contract. Let's discuss what we can apply from cluster to improve this architecture. And here's three properties which we will use in our discussion, and some approach how we can use it in our architecture. First one is that each transaction, is it sync or async, can hold tokens and pass tokens together in one call with the function call. It means that we can reduce, we basically can split 2 calls for transfer and swap in just on one. Less calls, more stability for systems, so I think it's good. And another one property, it's any smart contract on top of our cluster can be an owner of one and only one token. What does it mean? Usually Uniswap, when you provide some liquidity in pool, takes you some kind of tokens, liquidity provider tokens, which represents your share in the pool. So if you will take 10% of pool, you can bring for you 10% of liquidity tokens. If you want to get back your liquidity, you will just burn your LP tokens and get back all the tokens. So in Uniswap, you have separate contract for that. To reduce again calls between contracts, our cluster allows you to place this part of functionality inside just only one contract named pair. So you can create only pair, and inside of this contract you can place some functionality of minting, burning LP tokens. And last one, let's use multi-currency feature, one of the main feature of our cluster. So in our cluster, each smart contract have native balance and some kind of mapping to another tokens balances. It means that if for Uniswap you need to call smart contracts twice, for first token and for next token, on new cluster you can do it just in one call, because we already have 2 balances inside one smart contract. It means that, well, okay, let's call only once. Let's see what happens if we will apply all these features to our architecture. Well, it's look very good. For very naive implementation of Uniswap, we can deprecate router, but for production version of course not, because the router contains also not only balancing features but some estimate things. So anyway, you can see that we reduced a lot of calls. Pair contract now can do just all the functions inside just only one contract. We reduced a lot of calls, and well, now our architecture looks very good. Let's talk about our next approach.
Sorry.
Let's use main features of our architecture, and let's think how it help DEX architecture to distribute the load. So, sharded architecture basically means that we have a couple of shards which acts like a semi-independent chain. Inside shards we can call synchronously 2 contracts. Outside shards or between shards, one contract will call another in asynchronous way. So let's apply it to our DEX. So our idea how to reduce latency, if we will talk about Ethereum, for example, we want to place all the contracts in parallel in couple shards. It means that in Ethereum, Uniswap will process transactions one by one. Here we will process transactions in parallel. It means that we can distribute the load between shards, and I think, well, it's the most clear feature we can apply for DEXs. It will be useful on the token sales moments and peak load. That's all from my side. Here are 2 QRs, one for our documentation and one for our careers. So, thank you.
Any questions?
Yes, yes.
Yeah, I think I have a quite related question. So you said that you could access to the same liquidity in parallel, right? Or it will be a different liquidity?
Uh, um, well, it depends on how you will distribute the contracts across shards. You can create one pair contract in only one shard, and it will be just only one place for liquidity. You can create same pairs in another shards, and liquidity will be distributed.
So if I place, for example, all liquidity contracts in the main shard or some specific shard and try to get access from other shards, it means that actually the load will be kind of landed in this shard where the liquidity is, right? Because it has to process all these transactions anyway.
Yes, and it can be a good way how to distribute the pair contracts, because, well, you can distribute the top loaded pairs across the shards, and distribute load them. So, yes.
Okay, thanks.
So it seems to be that the best approach when we have to make different transactions across different shards, for example, interact with one pair in one shard and another pair in another shard, is to create a new smart contract that can bundle all of these operations. Is it the case? Or because specifically for DEX applications, what happens when you need this parallel processing, for example, some pair has moved to a different exchange rate, for example, things like that.
I'm not sure that I understand your question correctly, but anyway, let's talk in this way. Could you please a bit more specific?
So it seems like you're bundling all of these operations into a new smart contract.
I understood. I think it's possible to create this bundling, but it's a question to latency of processing of these transactions. It should be very low. To achieve that, it means that in best case, all should be in one shard, because we can use synchronous calls. After that, I think the best approach will be to do some performance tests, because, it will be quite difficult architecture, and all should be mirrored.
In basically, if we start to do transactions across different shards, the best approach is to create a good contract that can work with asynchronous calls.
It's possible to do it, let's say like that. So you can place two contracts, you can call it asynchronously between two shards. It's question only for latency. If it will be better, so then okay, who knows?
So basically, I have a question, so first of all, which we have to use virtual machine?
Oh, it's EVM based.
It's a bit, okay, I got it.
Yeah. It's extension of the EVM.
Oh, yes. Yeah. Great. It's not very specific to this talk, but you said that the smart contract can hold single token at only only single token. Is it an architectural limitation, or is it a design choice?
It may contain different tokens too. I mean, it may have, I don't know, wrapped Ethereum, wrapped Solana, wrapped anything else.
I mean whole, not kind of this balance, but whole, mint and bird.
Oh. That was basically, it mostly was simpler way to manage that.
Oh, yeah, I see. Yeah. So it's design choice.
Yeah.
Okay. Yeah, thanks. And just was not enough. The very last slide should be much longer about parallels, because the most interesting part basically. Absolutely. Thank you.
Any other just loud questions?
Okay, thank you.